Hi friends, welcome back to Arc Electrical Grid. I hope you can hear me. If you have any problem, please let me know in the comment section. Just let me know. Am I audible? Yeah, today we are late because there was some technical error. I'm unable to connect immediately. So just now people helped me to rectify it. Is it fine now? Am I audible? Just let me know in the comment box. So I hope you all can hear me. So just recollect once again what are the things that we have discussed till now. So in the last session we were completed up to SCR, short circuit ratio. We have been discussed about characteristics of alternator. I hope you all remember whatever we saw. So from from today's session onwards, we are going to look into the third part of the electrical machines. What is the next third part? Till now we have been seen the two salient pole reactance theory, and we haven't seen the fundamentals of salient pole machine. We have been gone through only. Yes, you all can hear me. Let us continue. We have been gone through only the basics of cylindrical machines. So let us see, if I am taking salient pole, the concept of two reaction theory will fall in place when we are discussing about salient pole machine. When we are discussing about salient pole machine, let us start from here. So in case of salient pole machine, you might have observed, let us break it into two part. Salient pole machine, first one, let us take alternator. Things that you have to remember is, when we are looking into alternator, what you have to remember is the calculation of power factor angle tan psi equal to, we know the basic formula, it can be written as V into sin pi plus or minus armature current IA into quadrature reactance x cube divided by, it will be V into cos pi plus IA, sorry, plus IA into RA. Now here you can observe that in the numerator part I put plus as well as minus also. If you are using plus, basically it is talking about lagging power factor, and you also use the positive sign for unity power factor. When we are putting negative sign, that will be basically dealing with the leading power factor. Yes. And what is the expression for induced voltage when we are discussing about salient pole synchronous machine, salient pole synchronous alternator? The value of the induced voltage can be written as V times of cosine delta, that is cos delta, plus quadrature current IQ into armature resistance RA, plus or minus, you can say, that is ID into XD. After that, suppose if I am talking about salient pole motor, if we are talking about salient pole motor, then what can be the expression? In case of salient pole motor, the expression will become tan psi equal to, let us see, V sin pi minus plus armature current IA into quadrature reactance x cube divided by, it will become once again V into cos pi minus IA into RA. Just observe the difference. Here it is plus. Wait. Yeah. So if you are observing here, here it is plus. Whereas in case of motor, this portion will become minus. That is the first difference. And if you are trying to calculate, once again, for lagging power factor, you have to put minus in case of motor. Undoubtedly, minus will appear for lagging power factor. And this positive sign will be leads for leading power factor. You have to use positive sign in the numerator for leading power factor or unity power factor. So that is very important. After that, so this is all about the basic equations that you have to remember when we are talking about a salient pole synchronous machine. And the induced voltage formula, if you want, it is very rare to frame the questions from these areas. but you can still remember it. You can expect, that is IQ into RA minus plus ID into XD. Standard, same relation, you have to use minus for lagging power factor, plus for leading under unity power factor. Now, let us keep our attention with the next part, that is simply called slip test. So when we are keeping our attention with this slip test, with the help of a slip test, basically we are trying to measure the value of direct axis reactance and quadrature axis reactance in case of Salient pole synchronous machine. So we are completely talking about Salient pole synchronous machine. We have been discussed about the basic internal power factor angle. I hope you all know this. This is output, that is external power factor angle, relation between voltage and output current, and that is external current, armature current, and this is quadrature reactance. This is armature resistance, and this is the total current, armature current taken by the machine motor, that is V is phase voltage, terminal voltage. That's all. There is no big difference. And here XQ and XD stands for quadrature reactance and Salient pole machine. That is quadrature reactance and direct axis reactance of the Salient pole machine. Sir, how to measure these two values? For that, I am going with the direct axis reactance, that is the ratio between Vmax per phase voltage, that is per phase maximum voltage divided by minimum current per phase. Similarly, when we are talking about quadrature axis reactance, it will become minimum voltage per phase upon, we can say, maximum current per phase. That's all. Everything will be given. All you have to do is just substitute the data to figure out the answer. Finish. Now, next, let us see the power flow equation of this alternator, because that is very important. Let me write both for cylindrical and Salient pole machine. That is, if you are observing the power flow equation of the alternator, keep the heading. We are going to discuss about power flow equation. Power flow equation of alternator. Power flow equation of alternator. So when we are talking about power flow equation of the alternator, the first thing is, suppose if I am taking power flow equation of the cylindrical rotor synchronous machine, if I am taking cylindrical rotor synchronous machine, then what can be the formula to calculate the real power and reactive power? Just write down. The formula for real power is simply what? EV by Zs into cosine of theta minus delta. See, this theta delta at all already I have explained in the last class itself. If you are having any doubts, please watch the last lecture. Minus, it will become V square divided by synchronous impedance Zs into cos theta. Similarly, reactive power will become EV by synchronous impedance Zs into sine of theta minus delta minus V square into synchronous impedance Zs into sine theta. After that, what will happen is, here you will be requested to find the maximum power. So this is the real power condition. Now how to achieve the maximum power? What is the formula to calculate the value of maximum power? The maximum power will become EV by Zs minus V square by Zs into cos theta. Whereas maximum power can be achieved when the value of theta will become equal to the value of delta. That is the condition for maximum power. Condition for maximum power achievement in case of synchronous alternator. Next, if we are talking about Salient pole machine, if we are talking about Salient pole synchronous machine, this will become power P is equal to, the formula is once again EV by direct axis reactance XD into sine delta plus V square by 2 times of 1 upon x cube minus 1 upon xd into sine delta. That is, sine twice of delta will appear here, just to remember this. Next, various, the first portion is called, we know this is called electromagnetic power. The first portion is called electromagnetic power. What about the second portion? The second portion is called reluctance power. So this is called reluctance power. So in your examination, while talking about the salient pole machine, it is very important to observe these two things carefully. What will happen is sometimes they will be asking the total power, sometimes they will be asking only calculate the reluctance power of the salient pole synchronous machine. Sometimes they will be asking only calculate the electromagnetic power of the salient pole synchronous machine. So it is very important to remember all type of relations. And apart from this, the most important parameter is you are supposed to calculate the synchronizing coefficient. Synchronizing power coefficient. We can call it as synchronizing power coefficient. What is the formula to calculate the synchronizing power coefficient? That is simply PSY equal to synchronizing power coefficient EV by synchronous reactance XS into cos delta. So this formula is valid only for this formula is only valid for cylindrical machine. This formula is only valid for cylindrical machine. Then suppose if you are requested to calculate the synchronizing power for salient pole machine. For the salient pole machine, this formula will become EV by direct axis reactance XD into cosine of delta plus V square into 1 upon X cube minus 1 upon XD into cosine of 2 times of delta. Now here what you have to observe is just it is nothing but synchronizing power is nothing but the differentiation of real power with respect to delta. That's all. If you are differentiating the real power with respect to delta, that will give you the value of synchronizing coefficient of both salient pole machine and a non-salient pole machine. Understand? Now let us discuss about the parallel operation of the alternator. The next part, parallel operation of the alternator. While connecting two alternator in parallel, the things that you have to remember. First one is when the moment we are connecting the two alternators in parallel, and of course they will be going to be loaded. There are different conditions will be appearing. First, what will happen is in alternator, there are two main sources we have to talk. Whenever we are thinking about the alternator, we will be always keeping two heart inside the alternator. The first heart is excitation. This exciter will taking responsibility for reactive power. The second one is prime mover. The second one is prime mover. Now, always keep in mind that by changing the excitation or by changing the prime mover, what can we do is we can give changes in the reactive power and real power delivery of the machine. Let us see one by one. The case number one is suppose if I am changing the prime mover, that is we are calling it as steam input. If you are changing the prime mover and the excitation is maintained as constant, then what will happen? Suppose, let us assume there are two alternators which are connected in parallel. Two alternators are connected in parallel. Two alternators are connected in parallel. Two alternators are connected in parallel. So when two alternators are connected in parallel, there will be two machines, right? Now let us take alternator 1 and let us take alternator 2. What will happen here? We have to compare both of these alternators, the changes. So now what we are going to do is under this situation, we are taking two alternators which are connected in parallel and I am going to change the steam input or prime mover. I am going to change the steam input. Thermal power is the one that is we are considering in India. 70% of the power grid is being, what we are doing is 70% of the power production of the power grid is depends on steam input, that is thermal power. And most of the operation is what? Steam everywhere in nuclear power plant, steam power plant. There are some other sources where we are not talking about the steam. Other type of energy conversion is possible, but the majority is steam input. That's why we are keeping the name itself steam input. Actually, we are changing the prime mover. That is the common word that you can observe everywhere in case of alternators. Okay, steam input or we are changing the prime mover and we are trying to maintain the value of excitation is constant. So the value of excitation is constant here. So excitation is constant, we are changing the prime mover. Now what will happen? There are two cases. Under this situation, steam input you can increase for any one machine. For an example, suppose if I am increasing the steam input of alternator 2. The question is whether the steam input, whether we are increasing the steam input for both machine or only one machine. Only one machine, for only one machine we are going to increase the steam input. I am taking in alternator 2, suppose if I am increasing the steam input, let us see what will happen. You can keep the same data for the other machine also. If I am increasing the steam input of the alternator 2, then immediately what will happen in the step by step in the real power. If I am talking about the real power, since I am increasing the steam input of the alternator 2, so definitely real power of the alternator 2 will increase. At the same time, if you are observing the real power of the alternator 1, real power of the alternator 1 will decrease. Okay, that is the first observation. I am not deriving anything here, just I am giving the notes. Suppose if you are in the same fashion, if you are observing the reactive power, since I am changing only steam input, steam input is directly dealing with the only real power, it will not touch reactive power. So what I can say is reactive power of the both machine will be remain same, they will not change, they will not vary, they will not vary. Reactive power will be remain same in both machines, there is no any changes. Now if you are keeping your attention with the apparent power, as we saw already, real power is increasing, reactive power is constant. So definitely apparent power will increase, and here definitely apparent power will decrease. Yes. And the next thing is, while increasing the steam input, armature current supplied by the alternator will increase in the second case. Whereas in this first alternator, armature current supplied by the alternator will get decrease. Similarly, if you are observing power factor of the machine where we are increasing the steam input, that will increase. Whereas here the power factor of the machine, the one that is in opposite, that will decrease. So what is the conclusion? Overall changes is whenever you are increasing the steam input of the any one alternator during the parallel operation, that changes will be reflected in the real power, apparent power, armature current, power factor, all the quantities will increase to the correspondent alternator where you are increasing the steam input, whereas the another alternator which is connected in parallel, there all the parameters will going to be decrease. Real power will decrease, apparent power will decrease, armature current will decrease, at the same time power factor also will decrease. But while changing the steam input in both alternator, the quantity which is not changing, which is always constant, is called what? That is reactive power. Reactive power will not change at any cost. Understood? I hope you got the clarity. Now let us go ahead with the next case. What is the next case? In the second case, what I am going to do is I am trying to maintain the steam input is constant. Let us maintain the steam input is constant, or I can say prime mover. If prime mover is constant, then which quantity we are going to vary? When we are connecting the two alternators as usual, while connecting the two alternators, let us take alternator 1 and alternator 2. What we are going to vary now? Excitation of the machine will going to be, we are going to vary the excitation of the machine. So let us take, once again I am taking the alternator 2 and I am increasing the excitation of the alternator 2. When the moment I am increasing the excitation, what will happen to the real power? As we saw already, excitation is directly dealing with the reactive power. It is not touching the real power. Whereas prime mover is directly dealing with the real power, it will not touching the reactive power. So when the moment you are trying to do some changes in the excitation of the alternator, obviously there will be no changes in the real power. You can say the real power of both machines will be remain same. There will be no changes. Whereas I am trying to increase the reactive power of the alternator too, so this will increase. So in the another machine, alternative side, reactive power of the machine will be decreasing. Q1 will decrease. After that, if you are observing, see there, reactive power is increasing. Obviously, it will leads to apparent power. Yes, apparent power will increasing here, whereas here apparent power will decrease. After that, while increasing the reactive power, excitation, as usual, armature current will be increasing in the machine 2, where only I am increasing in the excitation. Then in the opposite machine, armature current will decrease. Whereas, when you are observing the power factor, Since we are increasing the excitation, it is increasing the reactive power. When the moment your machine is started delivering more and more reactive power, then the power factor of the machine will become poor. So what will happen here is power factor of the machine 2 will decrease. Power factor of the machine 1 will increase. That's all. I hope you all understood the difference between these two. Now let us understand further during this parallel operation. When the moment we are trying to change in the steam input or mechanical power, whatever, right, and the excitation we are trying to maintain as constant, what are all the changes in the region of leading power factor and the lagging power factor? A little bit attention is required in the power factor of the machine, because that is very important. Now when we are observing the leading power factor region, as usual, let us take two alternators A1 and A2. Both are going to be connected in parallel. And here what I am going to do is I am going to change the steam input. I am going to change the steam input, and I am trying to maintain the value of excitation is constant. I am trying to maintain the value of excitation is constant. Under this condition, let us bring the relations. Let us bring some relations. What are the relations? What are all the relations that we have to observe? When the moment I am trying to increase the value of steam input, definitely you can observe. Suppose if your alternator is being operated at the leading power factor region, then if you are observing first thing, the changes in the reactive power. Since we are changing the value of steam input, I am trying to maintain the value of reactive power is constant. Sorry, I am trying to maintain the value of excitation is constant. Then what will happen? The reactive power absorption. Now let me conclude everything. The power reactive power absorbed by the alternator in the leading power factor region will be directly proportional to load of the machine, or I can say it will be directly proportional to steam input. Don't get confused with the previous statement and the present statement that I am giving now. Previously what I told, there is no any changes in the reactive power. Leave that statement. I am not talking about did I talk about the nature of the power factor here? Leading power factor, lagging power factor? No. When specifically alternator is being operated at the leading power factor region, under such a condition, in such a condition, if you are observing the reactive power consumed by the alternator, this will be directly proportional to steam input or directly proportional to load of the alternator. At the same time, real power also will become directly proportional to load and directly proportional to steam input of the alternator. Something you have to remember. And the next one is power factor. If you are observing, power factor is directly proportional to, sorry, inversely proportional to steam input. Of course, it is also inversely proportional to load of the alternator. Understood? Just to remember these things. Now, suppose if our alternator is being operated in the lagging region. If you are operating the alternator in the lagging region, what I can say is you can take the direct relation. Power factor will be directly proportional to load, and of course it is directly proportional to steam input. It is directly proportional to steam input. Okay, sir. At the same time, here during the lagging condition, your alternator will tries to deliver the reactive power. This delivery of the reactive power also will be inversely proportional to steam input. So there are different types of operating conditions, different regions. If our alternator is being operated at the lagging power factor, then it will try to deliver the reactive power. If it is operated at the leading power factor, then it is trying to consume the reactive power. That consumption of the reactive power rating is directly proportional to reactive power supplied by the load. That is what we are observing here. So here alternator is delivering the reactive power because it will be operated at a lagging reactive power. And what I can say, the most important point, delta, power angle, load angle. So the delta will be directly proportional to load. The delta will be directly proportional to load, or I can say it is also directly proportional to steam input. This delta is remains same in both cases. Here also, if you are writing the relation for delta, here also this will become delta is directly proportional to load. Of course, it is also directly proportional to steam input. Understood? Yes, I hope you all understood what I am trying to mean it. Next, let us see when the moment I am talking about the alternator, you have to remember the types of the excitation and the correspondent power factors. See, whenever I am talking about the alternator, the first thing, if our alternator will be operated at a normal excitation, if you are operating the alternator at a normal excitation, if you are operating the alternator at normal excitation, what will happen is it will not absorb any reactive power. So alternator operates at a unity power factor. Operates at a unity power factor. That is the first conclusion. Suppose if we are operating the alternator at a under excitation, if it is operates at a under excitation, then the power factor will be what? Leading in nature. Power factor of the alternator is leading in nature. And of course, just now we saw that is under excitation means operator is operating at a leading power factor. At a leading power factor, it will be absorbing the reactive power. It will be absorbing the reactive power. Then over excitation. If you are talking about the over excitation, then correspondent power factor will become lagging power factor, and definitely it will going to deliver the reactive power. Understood? Now this is all about alternator. If I am putting all this for motor, see at a normal excitation neither absorb nor deliver the reactive power. That is very important. It will not absorb, it will not deliver the reactive power. Under what? What is the condition? This condition is true when we are talking about the alternator. Under which situation? You have to observe this under unity power factor. If I am talking about the motor, in all these three situations, if I am talking about the motor, first, under normal excitation of the motor, as usual, it will be operated at the unity power factor, neither absorb nor deliver the reactive power. And the second case, if it is operated at the under excitation, in case of motor, under excitation, alternator is absorbing the reactive power. When I am talking about under excitation, what our motor will do, what can be the power factor? See, here it is, alternator is operated at a leading power factor, then this one will be operated at a lagging power factor. Understood? And of course, it will going to absorb the reactive power here under this region. Similarly, if you are talking about over excitation, power factor will become leading power factor, and what about the excitation? Power factor will be leading power factor, and it will going to delivers the reactive power. So observing and delivering is what? It depends on the nature of the power factor for both machine. Okay, I hope you all understood the difference between alternator and motors. Fine, sir. The next most important thing that you have to observe is, see, this is quick revision class. I know I'm not giving proof or anything. I'm just saying that key points. I'm just giving the key points because directly you can expect all the questions in your examination. By remembering all the key points, if you are trying to solve the problem, definitely you can. Nothing you will find new. Now, let us take V curve versus inverted V curve of the alternator. After that, we will be talking about motor. V curve and inverted V curve of the alternator. How will you draw the curve? For that, just choose the x and y axis, V curve and inverted V curve. So you will be observing there are V curve, as well as we are also going to observe inverted V curve. The thing says, if I am breaking this curve into two of, first what will happen is center point. This region is called normal excitation. Prior to this whole region is called under excitation. This whole region is called over excitation. Okay, there will be totally four regions: normal excitation, under excitation, over excitation. Now, under excitation, alternator, what will be the power factor? Leading power factor. Over excitation, alternator, what will be the power factor? Lagging power factor. Got it? And whereas we will be drawing this curve for two people. One is armature current, and another one is power factor, and exactly at the center point power factor of the machine will be unity power factor, whereas towards right and left hand side, you know already it is available, it is given leading and lagging power factors. Understand? This is how we are drawing the curve versus armature current versus we are drawing it for field current, and again unit power factor, not unity power factor, power factor versus field current. So here power factor versus field current, that is also projected, and armature current versus field current also projected. Just observe the waveform and how it is pattern is. Okay. Now when we are talking about the V curve and inverted V curve of the motor, V curve and Inverted waveform of the motor. When I am talking about the motor, what I can say is, once again, draw the same pattern. You have to draw the waveform. Again, break it into two off. Now what I am going to say is, this will be your armature current waveform and this will be your power factor waveform. First thing. And at the center point, your alternator once again will be operated unity power factor. Whereas if you observe towards right hand side, the power factor nature of the alternator is leading power factor. Towards left hand side, the nature of the alternator is, sorry, not alternator, motor, sorry. Motor is lagging power factor. Okay. Just note it down, and as usual, this is normal excitation, and on the left hand side here you can observe over excitation. Yes, here it is under excitation. Okay, and here one more thing is, what is the relation between field current versus power angle? Field current versus power angle. So let us draw. If I am drawing the field current versus power angle, so this is field current IF. This will be power angle delta. If you are varying this, when field current is very high, delta is very less. When field current is slowly increasing, then what will happen? Sorry, delta is very high. When field current is very less, when you are continuously increasing the value of field current, then the value of delta will be slowly decreasing. That is also from the graph only we are observing here. Understood? I hope you all got the complete clarity on the synchronous machine. I have covered the important thing, whatever the things that are required from the synchronous machine. So in the next class onwards, which machine shall we start? Choice is yours. We have already decided to start with the synchronous machine. After completing this, I told that we will be going up with the DC machine, then induction machine, then transformer. Okay, there is an order for everything. So next class we are going to start. We will be giving introduction for induction machine. We have successfully completed synchronous machine, and I have delivered all the most important point whatever that are required for you. Just to make a proper note. Remember one thing, just by observing the content and making the notes does not help you to do anything. What you have to do? After observing the content, try to utilize it effectively. Try to solve as many problems as possible. That only will be help you to boost your score.